Today we are going to understand the concept of Shannon Fano coding. Shannon Fano is a source coding technique. There are two source coding techniques. One is Shannon Fano, another is Huffman. First, in today's lecture, we are going to understand the concept of Shannon Fano coding technique. In both the methods, we need to calculate the coding efficiency. The formula for coding efficiency is coding efficiency. It is denoted by eta, which is equal to hx upon L bar log m, where hx is the entropy, L bar is the average length, and m is the number of symbols which we are going to use for the coding purpose. So this formula is same for both the methods, Shannon Fano and Huffman. To understand the concept of Shannon Fano, how Shannon Fano coding works and how we can calculate the codes of this method, for that we will take an example. Let us say a source transmits few messages having probability 0.2, 0.4, 0.08, 0.04, 0.08, 0.12, 0.08. You have to calculate the coding efficiency for this method. So the very first step to solve this method is, if you are given few probabilities, the very first step, which is very essential, if you forget that step, the whole problem will get incorrect. So the very first step is we have to arrange all the probabilities in descending order, and then after that we will perform the second step, which I will discuss. So as per the step 1, we need to arrange the probabilities in decreasing order. So the decreasing order of the probabilities would be 0.4, 0.2, 0.12, 0.08, 0.08, 0.08 and 0.04. Now after arranging all these probabilities, now the question comes whether we have to solve this question using m is equals to 2 or m is equal to 3, where m is the number of symbols. So it will be given in the exam whether you have to solve it with the help of m is equal to 2 or 3. So let us solve this question for m is equal to 2. So if m is equals to, that means you have two symbols. So we have to divide our probabilities into two sets of equal values. Equal values of two sets means the total probability is always 1. So the equal ideal condition should be 0.5 and 0.5. But it is not always necessary that all the sets will be equal with the same probability, because the probability may differ in the values. So such as in this case, you can see that either we can divide these probabilities by taking in the first set 2 messages and in the second set other messages. So the first set total probability is 0.6 and the other set the probability is 0.4. So this is, you can say, nearly equal. So after dividing the values in two different sets, we will assign one symbol to one set. One symbol means 0 and the other symbol to another set. After assigning these messages or these symbols, now our next step is to subdivide your set into again equal values, so that all the messages will be having unique codes. Our main aim is to get all the messages a different code. So in set 1 we have two values or two messages. Again, if you divide this set into two subsets, first set will get first symbol and second value will get, second subset will get second symbol. So the message 1, which is having probability 0.4, will be having code 00, and message 2, which is 0.2, is having code 01. Both the codes are different, So now code of 0.4 and 0.2 is complete. Now let us move to set number 2. Again we will divide this set number 2 into two equal subsets. So the division would be something like this. 0.12 and 0.08 will add up to 0.2, and these three values again 0.2. So almost equal division. Again we will assign one symbol to this subset, another symbol to this subset. Same procedure, because these two codes are same. To make it different, we will assign one symbol to this, another symbol to this. Now coming back to set number 2, second subset, we have three messages. Again we have to divide it. So for one set we take this message, for the another set we take these two remaining values. So we are assigning this 0 to this and 1 to this. As you can see, these two are unique. Even this is also unique, but these two are again same. So that means we have to subdivide again, give it 0, and this is 1. So this is how the final coding is done. After the final coding, the code length is 2. That means you have two symbols. So the code length of this particular message is 2. For the code length of this message is also 2. Then 3, 3, 3, 4 and 4. Here understand this thing, that these values are not you have to convert into decimal. Just you need to calculate or count the values or count the symbols, how many symbols are there in a particular message. 2 symbols, that means length is 2, and so on. So now we have to calculate Hx, entropy. Formula for entropy is summation I is equal to 1 to n pi log 1 upon pi. How many messages are there? 7 messages, that means 7 probabilities. So this n would be 7. So this will be from I is equal to 1 to 7. It will become 0.4 log 1 upon 0.4 plus 0.2 log 1 upon 0.2 plus 0.12 log 1 upon 0.12 plus 0.08 log 1 upon 0.08. This value comes thrice, so we can simply multiply it with 3 and then plus 0.04 log 1 upon 0.04. So after writing all these values, now you have to calculate the value of Hx. So Hx is 2.42. This you have to calculate. Then the next value which we need to calculate is L bar. The formula for L bar is summation Ni into Pi, where I starts from 1 to n. All the messages we need to consider. Ni is the length of ith message, Pi is the probability of ith message. We have 7 messages, so L bar would be 0.4, the first probability, and the length of this particular probability is 2, 0.2 into 2 plus 0.12 into 3 plus 0.08 into 3 plus 0.08 into 3 plus 0.08 into 4 plus 0.04 into 4. So this would be your L bar, which comes out to be 2.52. This you have to calculate. And then finally efficiency, which is eta. So that we will calculate. So the formula for coding efficiency, eta is equals to Hx upon L bar log n. Hx we have calculated as 2.42. L bar we have calculated as 2.52 into log m, where m is equal to 2. That means it is log 2. Log 2 base 2 is 1. So this value doesn't affect this overall value. By calculating, you will get 0.96. So the percentage efficiency is 96%. This is how we can calculate the coding efficiency using Shannon Fano coding technique. I hope you understand using this example. Thank you for watching.